Hello guys, in this video I will solve the exercise number 3 on page 109, and it says an arrow is shooted at 60 degrees, at 60 meters per second, and it reaches a maximum height of 150 meters. They don't give you angle, they don't give you the range or any other information. So we have to get letter A, the angle of elevation, that is the launching angle, and letter B, the time to maximum height. Here, the data that you have, if you use the first half, is the initial position in the x-axis, the initial position in the y-axis, and that's it. Both of them are 0. However, you cannot use any formula with only that information to calculate time. Why? Because you don't know the final position and you don't know the time. For here, you don't know the final position in the, oh well, you know the final position in the y-axis, but you don't know the initial position in the y-axis, the initial velocity, sorry, in the y-axis, because you don't have the angle. So you have two unknown variables. And here you also have two unknown variables. When that happens, when you only have the initial velocity and the height, you need to use the second half of the trip. That it's symmetrical, so it will be the same, but some variables are different, and we will see why while we solve this exercise. So it will be the data for the second half. And let's see. The initial position in y-axis is unknown. The final position is also unknown, and we won't need them. The initial position in the y-axis, if now is going from the top to the bottom, the initial position is here and the final position is here. So it will be 150 meters. And the final position will be 0 meters because it's the ground. The initial velocity of the whole trip is 60. And if that is 60 and it's symmetrical, what's the final velocity? Remember, it's symmetrical, so it will be the same but in the opposite direction. So the final velocity of the whole trip, it's minus 60 meters per second. Why? Because the initial velocity of the whole trip is 60. They are the same, but in the opposite direction. We will use this one. And then we have that we don't know the angle, we don't know the time to the maximum height, and the acceleration in the y-axis is equal to minus 9.8 meters per second squared. So in this case, it's better to calculate first the time. So let's get the time. And with the information that we have now, we can use the formula that it's here. And let's see why. We will use this formula because we know the information that is contained in that formula. We know the final position, the initial position, the acceleration, and we want to calculate time. And also the initial position in the y-axis, the initial velocity in the y-axis, given that it's free fall and it starts from the highest point, how much is that? It will be 0. So we cancel this. And the formula for time will be time is equal to the square root of final, or 2 times the final position minus the initial position divided by the acceleration in the y-axis. That is 2 times 0 minus 150 meters divided by minus 9.8. Try to calculate this. The number must be positive because it will be 2 times minus 150 minus 300 divided by minus 9.8, and the square root of that will be, if you don't have the time, pause. If you don't have the answer, sorry, pause the video. However, I got 5.53 seconds, and that's the time to the maximum height. That's the time from the highest point to the bottom. So it will be the same for the upwards motion. So that's the answer to letter B. The time to maximum height is the same as the time from the maximum height to the bottom. And now the angle. The angle is a little bit trickier. And it's calculated by using this formula, right? But we have a problem. We need to calculate, well, the formula says that it's the angle, it's equal to tangent, inverse tangent to the velocity in the y-axis divided by the velocity in the x-axis. In this case, it's about the final velocities. Final velocity and final velocity. Because we have the angle here that will be equal to the angle here. So we have to calculate both. So the final velocity in the y-axis first. Do we have a formula for that? Yes, we have a formula for that. And it says that it's equal to the initial velocity in the y-axis, which we know that it's 0 meters. In the second half, remember, this is the initial point, so the initial velocity is at the highest position, and it is equal to 0 meters per second. Plus acceleration minus 9.8 meters per second square, multiplying time, 5.53 seconds. And I got, as final velocity in the y-axis, let me do the operation, and it will be equal to, oh sorry, you can do the operation with me, minus 9.8 multiplying 5.53, and I got minus 54.109 meters per second. You can have a different answer, maybe because if you include more decimals. So that's the final velocity in the y-axis, and we know the final velocity. So we can use this other formula to calculate the final velocity in the x-axis. And final velocity, it's equal, final velocity square, it's equal to the final velocity in the x-axis square plus final velocity in the y-axis square. I want to solve for this. So it will be final velocity square minus final velocity in the y-axis square, because this is positive, pass to the other side as negative, and that will be equal to final velocity in the x-axis square. I got this square root to eliminate that, and it will be equal to the square root of final velocity minus 60 square minus 54.19 square. And the final velocity in the x-axis will be, let me do the operation, you can do it with me, negative 60 raised to the square. Remember to include the negative 60 inside the parentheses. Minus 54.19 square. And I got 25.76. meters per second. And now we can solve the formula. It says that the angle it's equal to the inverse tangent of final velocity in the y-axis minus 54.19 divided by 25.76. So calculate that inverse tangent of negative 54.19 divided by 25.76. And I got an angle of minus 64.6 degrees. And that angle it's here and it is negative. So at the beginning it will be positive. The launching angle, this is the landing. How do I know? Because I was using the second half and this will be the initial angle, the launching angle. And that will be the second answer. And that's it. That's it for the video.